So continuing on with our trig unit, we're going to take a little bit more into angles, coterminal angles, some different vocab, how we draw them, all this good stuff. So just some basics to begin with. When we are looking at an angle, the beginning position of the ray is called your initial side. And it's rotated about the endpoint called the vertex. And the final position is your terminal side. So your angle is always going to open up starting at the initial going to the terminal. The measure of an angle is a number. It's going to describe the amount of rotation from that initial side to the terminal side. If we have a positive angle, that's going to be because we are moving in a counterclockwise motion. This is big. And if we have a negative angle, that's because it's going in a clockwise rotation. So that direction will be big, especially the further on we get with our trig unit. Okay, so we're going to draw a couple of pictures down here. So taking a look at the initial and terminal side, we have a standard position, and it says the vertex of an angle is at its origin, and its initial side is lying across that positive x-axis. So if I were to look at this, I could say, here's my initial side, maybe here's my terminal side, and since I'm opening in that direction, I can tell you that that's going to be a positive angle. And I could have pretty much that same picture, but the direction maybe is just going to change. So same idea, I could have this being my initial side, this being my terminal side, but I'm going in that clockwise motion. So now I have this, it looks the same, different angle, right? So I would say here's like maybe angle alpha, here's maybe angle beta, and I could tell you that this angle would be considered a negative angle just simply because of the direction that we open the angle up. Okay, so now we have things that are called coterminal angles. So it says two angles in the expanded angle measurement system can have the same initial and the same terminal side yet have different measures. And we're going to call those coterminal angles. So they will be wherever they differ by an integer multiple of either 360 or by 2 pi, depending on how we're measuring our angles. So again, I'm going to draw a couple of pictures, give you an idea. So if we are looking, let's take for instance that picture that we had up above. So I had my initial side, my terminal side. I had that angle was alpha. I had this angle was beta, and I could call those angles coterminal angles, one being positive, one being negative, but they're coterminal meaning they're ending in that same location. Okay, so that's an example of a positive and a negative coterminal angle. You could have two positive angles. And remember what we said, they would differ by an integer multiple of 360. So for instance, maybe I had an angle here, where I could say just opening this angle up would be perhaps angle alpha. Okay, now a coterminal angle, if it's differing by an integer multiple of 360, would basically be this angle, but all the way around the circle and ending back in that same location. Okay, so I could have perhaps, and notice they're going in that same direction. Two positive coterminal angles, just one is going to start from the axis up to the side, one's going to go around from the axis all the way around back to that same ending location. Okay, so calculation-wise, what is that going to look like? So if we're trying to find coterminal angles numerically, we know that they're going to differ by 360. So I could find a positive and a negative coterminal angle. So if I wanted to find a positive coterminal angle and it differs by 360, I could just think add 360. Okay, so 30 plus 360, that would get me 390. So a 30-degree angle and a 390-degree angle, they could be coterminal. So for instance, back at this picture, if I were to tell you this angle up here was, let's say, 30 degrees, by going all the way around again under full 360, I could also tell you this could be a 390-degree angle. Now, we could also subtract 360 from this. So if I did 30 minus 360, I'm going to have a negative 330. So notice again, negative, meaning I would be going in that clockwise direction, but I could end up in the same location. Okay, so if we try another one here. So if I have negative 150 and I add to that a total of 360, going in that positive direction, I would get 210. So they would be coterminal, negative 150 and 210. I could also subtract 360. So by subtracting 360, I get a negative 510. So think about what that means. You're going around the circle more than once. So we're going around that circle and then some, another 150 degrees. And those could be coterminal angles. Now, as far as this being in radians, until you're super comfortable, if you wanted to convert this into degrees and then do the same calculation, you could. 2 pi over 3 does convert to 120 degrees. I'm going to try and show it to you in radians. So we said it could differ by a value of 2 pi radians. So I'd have to add 2 pi to that. Now, when you're adding fractions, you want to think common denominators. So a common denominator here, I would have to turn this into a 3, which means I'd have to multiply that by 3. So really this is like saying 6 pi over 3. So if I have 6 pi over 3 plus 2 pi over 3, that's going to give me a total of 8 pi over 3. And we could do the same thing, but now this time I'd want to subtract this out. So I'd want to subtract out 2 pi. But again, thinking about what we did up above, I would have to have a common denominator here, which would really make that 6 pi over 3 again. So 2 pi over 3 minus 6 pi over 3 would leave me with a negative 4 pi over 3. And again, if we're not comfortable in radians, you could do it in degrees and then just do a conversion, but we will get there. Okay, so what happens if I actually now need to draw this? So trying to put an angle into standard position. Just keep in mind, initial side is always on the x-axis. And it says the terminal side contains the point 5,3. Okay, so if I just drew a rough sketch and I'm thinking the point 5,3, so I have to go over to the right 5, I have to go up 3 units. So this point that it's going through, let's say, is right here. So now I have an angle. Here's my initial side, here's my terminal side, and I could start to form a triangle. Okay, so the distance on my x-axis, that's going to be a distance of 5. The distance on this y-axis, we're going up and down here, that's a distance of 3. And we could do Pythagorean theorem to find out our hypotenuse. Okay, so if we did 5 squared plus 3 squared, that's going to equal our hypotenuse squared. And if we solve this, I'm going to tell you that turns out to be the square root of 34. Okay, so we have to find all 6 trig functions. Okay, so starting off, I need sine of that angle. So sine being opposite over hypotenuse. We do the cosine. Cosine's adjacent over hypotenuse. So according to that angle, the adjacent side is 5 hypotenuse square root of 34. And the tangent of that angle is going to be our opposite side over our adjacent side. Now, to get the 6, now we have to think reciprocal functions. So the reciprocal of sine is cosecant, and we take the reciprocal of that fraction. The reciprocal of cosine, secant, and again, flip your fraction to get the value. And the function that goes with tangent is your cotangent. And again, flip your fraction. So there's your 6 functions. Okay. Now, things that we need to think about is our signs, our positives and our negatives. And when we're in different sections of our graph, we want to know, okay, are they going to be positive? Are they going to be negative? And we're going to take a look at 2 of them, and then we're going to expand off of this and give you a quick little mnemonic to help you remember. So they're saying for this question, if I'm in the section of my graph that ranges from 0 to pi over 2, pi over 2 is 90 degrees. So we're in our first quadrant. It says what would be the sign, meaning positive or negative, of sine, cosine, and tangent. Well, if I'm in the first quadrant, if I do a right motion and an up motion, that triangle, no matter what, when I draw it here, I know that this side is positive and I know this side is positive. So that means any sine ratio I make will be positive. Any cosine ratio I make will be positive. And any tangent ratio I make will be positive. Think. So sine, I have positive divided by hypotenuse. I have cosine, positive divided by the hypotenuse. Tangent, positive divided by positive. Everything's going to give us a positive. Okay. Slightly different when we get to this one now. So they're saying between pi, which is 180, and 3 pi over 2, which is our 270. Okay, so now if I were to make a triangle out of this, if I were to think, well, what if I had some sort of a triangle down here? And this is a little bit of reference angles, so if you can't remember this or it's a little fuzzy from Algebra 2, we'll cover this more in class. But we're now focusing in on our reference triangles. Keeping in mind, here's your initial side for your angle, here's your terminal side. We'd open it up this way. Now I'm thinking, so what happens if my angle is in this quadrant? Well, if I'm looking again at the direction, I can tell you this x value would be negative, and I could also tell you this y value would be negative. So what does that mean? So that means our sine ratio, when we try and make sine ratio, since I'm going to have a negative side here, will give me a negative ratio. Same thing for cosine. When we do the cosine, if I took the cosine of this, this is going to give me a negative, because cosine, I think I just pointed to the wrong one. Cosine should be adjacent over hypotenuse. So cosine is negative. If I did sine, it should be opposite over hypotenuse. So sine should still be negative. If we do tangent now, since we're doing opposite over adjacent, so I have opposite over adjacent, I have negative divided by a negative, which now makes this positive. So back in our days of Algebra 2, we had a little mnemonic that said all students take calculus. So what did that mean? That went with each of our quadrants. So we have A for all, S for students, T for take, C for calculus. And what that means is in our first quadrant, everything is positive, sine, cosine, tangent, and the reciprocals. In our second quadrant, only sine and its reciprocal, cosecant, are positive. That means everything else is negative. In our third quadrant, only tangent and its reciprocal, cotangent, are positive, which we just found, and everybody else is negative. And in our fourth quadrant, cosine is positive along with secant, and everything else is negative. So if we can remember that mnemonic, I think that would help us with our problems. So we're going to try that on this one. It says find the 6 trig functions for 315 degrees. So first we have to think, okay, 315 degrees is going to be in the fourth quadrant. So if we were to draw an angle, here's your initial side, your terminal side, it's going to go all the way around until I'm down here. That would be 315 degrees. But maybe I'm only going to just focus in on this triangle right here. Okay, now with 315 degrees, keeping in mind going back to Algebra 2 a little bit, I want to use this reference angle. So it's like saying, so what's left over in this little region? And since the whole thing would form 360, that means in this region, I would have left over a 45-degree angle. So from our last section, we talked about our 45-degree triangles, where we knew that this was 1, that was 1, and the hypotenuse had a value of square root 2. Keeping in mind our all students take calculus, now you have everything set on this paper to identify the 6 trig functions. So if we start this off with sine, so I'm looking for the sine of 315, I can tell you sine is my opposite over my hypotenuse, but in the fourth quadrant, it's negative. Cosine of 315 is adjacent over hypotenuse, and in the fourth quadrant, it's positive. Tangent of 315 is opposite over adjacent, and in the fourth quadrant, it is negative. So now we can find the reciprocal functions by just doing a flip. So the one that goes with sine we know is going to be cosecant. And we can say if I flip that, I'm going to have a negative radical 2. The function that goes with cosine is going to be secant. So secant of 315, again, if I flip it, it's radical 2. And the function that goes with tangent is going to be our cotangent, and again, reciprocal function. Now, if I flip a negative 1, it's going to just stay negative 1. So we have a couple to try, and we are going to actually break this video up because I think it's going to get a little long. So I'm going to stop this here. This will be part 1 of your video, and then we will continue on and do part 2.